that is another parameters, h parameters. The h parameter equations are v1 equal to h11 I1 plus h12 v2. Next, I2 is equal to h21 I1 plus h22 v2. These are the h parameter equations. Now here you tell me here what are the dependent, what are the independent variables here? What are the dependent and what are the independent variables here? Here v1 and I2, these are what? Dependent. These are what? Dependent. And this I1, V2, these are the independent. These are the independent variables. Simply, yes, for example, if they given y is equal to 3x plus 2, if they given something equation. Now tell me which is the dependent, which is the independent here. Y is a dependent on x now. If I change the different values for x, corresponding the y value will changes, isn't it? If I change the x values, corresponding the y value changes or not. So that means this y value depends upon x, isn't it? So that's why y is called as a dependent and x is called as independent. So simply the right side we have, those are called as a independent variables. Left side are called as a dependent variable simply. Right. Now, so these are the parameters. Now, so what we can say here, these parameters. Now matrix form we can write it as v1 and then I2, which is equal to, we can say these are H matrix. This is H11, H12, H21, H22. And then what else? I1 and V2. Yes, these are the H parameters. So this matrix generally we used to indicate with a H matrix like this. H matrix will indicate it. Now we'll see these parameters now one by one. How to find these parameters now here? One by one. The first one, H11. Tell me H11 is a H1. How to get H11 is a V1 by I1. And when V2 equal to 0, so let us better to write in the next slide. H11 is what? V1 by I1 when V2 equal to 0. This equal to 0 now. So what I can say now, this units are, and what the units are here? Ohms. Tell me what I can call them is a same port now. Then we should call them as what? A driving point. Driving point input impedance. Driving point input impedance. Right. So similarly we can write the remaining also. So tell me H1, H21. Tell me H21 here. H21. How to get H21 is I2 by I1. I2 by I1 when V2 equal to 0 now. And tell me what the units are. no units. It's a ratio now. So what I should call this as a output current by input current. So we can call them a current gain. What current gain? Forward or reverse? I can call this as what? Forward current gain. Forward current gain. Next, H12. H12 is what? V1 by V2 when I1 is equal to 0 now. So what I can say now here? And what are the units are? Here also no units. Here also no units. Then what I should call them name is a voltage ratios. We can say voltage gain. And forward a reverse voltage gain. Why? Because input by output we have not. Generally voltage gain means output by input, but here it is input by output. So that's why we can call this as a reverse voltage gain. A reverse voltage gain. So then H22, which is equal to what? H22 tell me now here. I2 by V2. I2 by V2 when I1 equal to 0. Here what's the units are here? Mho. Then what I should call the H22 is a same. So I can call this a driving point. Driving point. Output admittance. Driving point output admittance I can say. Right. Now these are the things we have seen it. Now we can see this carefully. Now here this, see the units are now here. Here this units are what it is a ohms. This is the current gain, voltage gain, and this is the impedance, admittance, voltage and current gain. All we have now. This is a mixer of all the things. So that's why which is called as a mixer. That's why which we used to call them as a hybrid parameters. Where this H stands for what? Hybrid parameters. Now we'll develop this equation here, network for this thing here. And you can say this is what? KVL equation, a voltage equation. This is a KCL. So KVL equation means the practical voltage source, practical current. So that means Thevenins and Nortons. Input is Thevenin and output is Nortons. Now develop this network here. Input is Thevenin. This is the input. Here the input is a Thevenin and this output is a Nortons. Nortons means practical current source. Port 1, this is my V1 and this current is I1. This is the V2 and this current is I2. Now I can say this is V1 is equal, this is H11 I1 plus H12 V2. Check this thing, first equation satisfy V1 H11 I1 H12 V2 simply by applying KVL in this loop. Next, and here this current now here, what I should call this current is now here, this is H12 into I1 and this is what? H22. Now tell me the KCL at this node now here. I2 is equal to V2 into H22, yes, plus H12 into I1. So H12 into, sorry, what it is, H21. This is what? H21 into I1. Check now, satisfy or not. H21 I1 plus H22 V2. And here H22, what is H22 is? 1 by H22. H22 is what? Is a admittance. So to get this current, what we should do? Admittance na, this is mho na, this H2 E2 units are mho. So that means we should divide or multiply. If it is a impedance, divide to get the current, but it is admittance na, so we should multiply with V2 to get the current. Right, like this we need to see this analysis. Now here also we'll see the condition for reciprocal and symmetrical now. Here the condition for reciprocal is little different to the earlier one. I can say if the determinant of this matrix, I can say H1 H matrix, H12, H21, H22, the determinant, if it is equal to 1, then we can call this network is a symmetrical. Then we can call the network as symmetrical. That is equal to 1 for symmetrical condition. Next, if H12 equal to minus H21, then we can call the network as a reciprocal network. That is equal to 1 for symmetrical and H12 is equal to minus H21 for reciprocal.